Okay, let's work through a few examples in 5.3. We'll just begin with one like the first one. So let's suppose we have log base 5 of 125. So remember, a log is an exponent. So what we're looking for is what exponent of 5 would make 125. So how many 5s multiplied together make 125? So 5 times 5 is 25. Times another 5, that would be 125. Hence, 5 to the third power is 125. So 3 is the answer. 3 is the power of 5 that makes 125. Okay, let's do another one. If we do log base 7 of 7, again, we're looking for what power of the base gives us this number up here. So 7 to what power makes 7? 7 to the first power. Anything to the first power gives you itself. So that's what we're looking for. How about log base 4 of 1? Well, if we do 4 to the first power, that makes 4, so that's not what we're looking for. If we do 4 to the second power, that's even bigger. That's not it. But remember, if we raise any number to the 0 power, that actually makes 1. Sometimes we forget that and we think, well, anything to the 0 power is 0, but any number to the 0 power makes 1. So regardless of our base, if we're taking log of 1, that is always equal to 0. So how about log base 3, 97? Well, if we try to multiply 3's together to get 97, we're not going to get that. 2 3's is 9. 2 more 3's is 9. Also, 9 times 9 is 81. So in other words, 3 to the fourth is 81. If we multiply times another 3, so 3 to the fifth, 81 times 3 is too big. So this is somewhere between 81 and 243. So that's where we have to use our calculator, and we have to use our change of base formula. That's where we do log of this number divided by log of our old base. We can technically change it to any new base that we want, but since our calculator has either LOG, which is by default base 10, or it has LN, which LN is just log base E. This is just a shorter way of writing log base E. Those are the two bases we're going to change it to. So we can do log base 10. Let's see. We can take log base 10 of 97 divided by log base 10 of 3. And we're going to get a decimal. Remember when we did 3 to the fourth power, we got 81. This number is a little bit more than that. So the exponent we're looking for is about 4.164. About 4.164. Remember, a log is an exponent. So when we're finding a logarithm, we're finding the exponent that when we put it on our base gives us that. So if we wanted to check, we could do 3 raised to the 4.164 power, and that's about 97. This will work regardless of whether we do log base 10 or natural log here. If we would have used natural log of 97 over natural log of 3, as long as we do this part on top, this part on bottom, and these bases are the same, whether it's log 10 or natural log, we're going to get the same answer. Notice if I do natural log of 97 divided by natural log of 3, I get the same answer. So that's how we handle a log that the answer doesn't come out to be an integer. Some of the problems may ask us to convert between logarithmic form and exponential form. So if we have 3 to the fifth power equals 243, if we want to convert this into a logarithmic equation, our base is 3, so that goes here. What the log is equal to is the exponent, so we put the exponent there, and then we put the other portion here. So that's converting from an exponential equation to a log equation. Let's say we have 2 to the x power equals 84. If we convert that to a log equation, we would have log, our base is 2, the exponent is what goes here, and 84 goes there. A log is equals an exponent. We can also go in the other direction. If we have log, let's say log of 279 equals x. There may not be any reason we would want to convert this to an exponential equation, but let's do it regardless. So if there's no base written here, that is an understood base 10. A log is an exponent, so the exponent is x, and what that is equal to is the 279. If we had log of x, let's say our base is 9, and then over here we put 7.4. If we convert that to an exponential equation, our base is 9, our exponent is 7.4, and that equals x. And let's do one more. Let's do natural log of 4.79 equals k. So if we were asked to convert that to an exponential equation, what is the base for natural log? It's base e. So e is our base. What the log equals is an exponent, and 4.79 is the other portion. So we can convert between exponential and log equations and going in either direction. Let's look at one more. Let's look at log base 2 of negative 16. And let's try to find the answer to this. So we're asking, what power of 2 makes negative 16? Now, with the change of base formula, we can just simply type that into our calculator. And if we do that, we would take log of negative 16, and this is, wait a minute, we can't do that. So we can't even divide it by log of 2, because when we take log of negative 16, we have a problem. So let's see why. So we're looking for what power of 2 makes negative 16. Well, if I do 2 to a positive power, like a positive 1, or a positive 2, or a positive 5, I get numbers that are all positive. What about if I use a negative exponent? If our exponent is negative, we get like 1/2, 1/4, 1/32. Notice those answers are all positive. They're getting closer and closer to 0, but they're all positive. And if we do 2 to the 0 power, we also get positive. So any power we raise, any power we put on 2, we get a positive answer. We're never going to get a negative answer for there. So that's undefined, or there is no solution to that. Even if we try to take log of 0, we're getting closer to 0 as our exponent becomes more negative, but there's no exponent that's going to give us exactly 0. If we try to take the log of 0, that doesn't work. So um, anytime we're taking the log, the domain has to be a positive number. Our input, when we finish plugging in, whether we have just a number x by itself or x plus something, once we simplify what's on the inside, that has to come out to be positive, or we're not able to take log. So in this case, the domain is numbers bigger than 0.